1 2 1 2. All right, let's get into it. So, if-then statement. The if-then statement is the most simple control flow we can write. It tests an expression for truth and executes some code based on it. If flip is equal to 1, system.out.println heads. The if keyword marks the beginning of the conditional statement, followed by parentheses. The parentheses hold a Boolean data type. For the condition in parentheses, we can also use variables that reference a Boolean or comparisons that evaluate to a Boolean. The Boolean condition is followed by opening and closing curly braces that mark a block of code. This block runs if and only if the Boolean is true. So Boolean is valid password equals true. If is valid password, system.out.println password accepted. Prints password accepted. Int number of items in the cart equals 9. If number of items cart is greater than 12, system.out.println express checkout not available. Nothing is printed. If a conditional is brief, we can omit the curly braces entirely. If true, then that. Note: conditional statements do not end in a semicolon. The code editor contains an order class to track retail shipments. Write an if-then statement that prints high value item when item cost is greater than 24. So double item cost equals $30.99. Oh. If then else. We've seen how to conditionally execute one block of code, but what if there are two possible blocks of code we'd like to execute? Let's say if a student has the required prerequisite, then they enroll in the selected course, else they're enrolled in the prerequisite course instead. We create an alternate conditional branch with the else keyword. If has prerequisite, enroll in course, else enroll in prerequisite. This conditional statement ensures that exactly one code block will be run. If the condition has prerequisite is false, okay, I got you. So there's an if is filled value represents whether the order is ready to ship. Write an if then else statement that when is filled is true, print shipping. If is filled, system.out.println shipping, system.out. Oh, it needs to be in parentheses. If then else if, gotcha. We need to calculate the shipping costs for our orders. There's a new instance field, string shipping, that we use to calculate the cost. Use a chained if then else to check for different values within the calculate shipping method. So when the shipping instance field equals regular, else if shipping is equal to express turn 1.75 else turn 0.50. Nested conditional statements. The company offers a temporary deal that if the consumer uses the coupon SHIP50, The company will reduce the express shipping price. Let's rewrite the body of else if statement from the last exercise inside the else if statement. Create a nested if then statement that checks if coupon code is equal to ship 50. If the nested condition is true, return the value 0.85. If the condition is false, use a nested else statement to return the value 1.75. Switch statement, an alternative to chaining if then else conditions together, is to use the switch statement. This conditional will check a given value against any number of conditions and run the code block where there is a match. Here's an example of our course selection conditional as a switch statement instead. String course equals history, switch course, case algebra, break, case biology, break, and so on. This example enrolls a student in history class by checking the value contained in the parentheses course against each of the case labels. If the value after the case label matches the value within the parentheses, the switch block is run. In the above example, course references the string history, which matches case history. When no value matches, the default block runs. Think of this as the else equivalent. Switch blocks are different than other code blocks because they are not marked by curly braces, and we use the break keyword to exit the switch statement. Without break, code below the matching case label is run, including code under other case labels, which is rarely the desired behavior. We'll rewrite the calculate shipping method so it uses a switch statement instead. There's an uninitialized variable shipping cost in calculate shipping. Assign the correct value to shipping cost using a switch statement. So switch shipping cost. Alright. When shipping matches regular, shipping cost should be 0. When shipping matches express, shipping cost should be 175. The default shipping cost 0.5, 0. Make sure the method returns shipping cost after the switch statement. Possible lossy conversion from double to int. Oh. For this lesson, our code executed from top to bottom, line by line. Conditional statements add branching paths to our programs. We use conditionals to make decisions in the program so that different inputs will produce different results. Conditionals have the general structure: if, condition, else. So, cool. Introduction to conditional operators. Java includes operators that only use Boolean values. These conditional operators. Hold on, give me a second. These conditional operators help simplify expressions containing complex Boolean relationships by reducing multiple Boolean values to a single value, true or false. For example, what if we want to run a code block only if multiple conditions are true? We could use the AND operator. Or we want to run a code block if at least one of two conditions are true. We could use the OR operator. Finally, we can produce the opposite value, where true becomes false and false becomes true, with the NOT operator. Understanding these complex relationships can feel overwhelming at first. Luckily, truth tables, like the one seen to the right, can assist us in determining the relationship between two Boolean-based conditions. In this lesson, we'll explore each of these conditional operators to see how they can be implemented into our conditional statements. The text editor contains a reservation class we'll build in this lesson. Note the different conditional statements and operators that we're using to control the execution of the program. Move on when you're ready. Conditional AND. Let's return to our student enrollment program. We've added an additional requirement. Not only must students have the prerequisite, but their tuition must be paid up as well. We have two conditions that must be true before we enroll the student. There's one way we could write the code: if tuition paid, if has prerequisite, enroll student. We've nested two if-then statements. This does the job, but we can be more concise with the AND operator. If tuition paid and has prerequisite, enroll student. The AND operator, ampersand, is used between two Boolean values and evaluates to a single Boolean value. If the values on both sides are true, then the resulting value is true. Otherwise, the resulting value is false. This code illustrates every combination. Our reservation class has the method confirm reservation, which validates if a restaurant can accommodate a given reservation. We need to build the conditional logic into confirm reservation using three instance variables: restaurant capacity, guest count, is restaurant open, using if then else statement. If restaurant capacity is greater than or equal to guest count and the restaurant is open, print reservation confirmed. It's in the same parentheses, right? Yeah. Conditional OR. The requirements of our enrollment program have changed again. Certain courses have prerequisites that are satisfied by multiple courses. As long as students have taken at least one prerequisite, they should be allowed to enroll. So we're just doing an OR operator. On some occasions, the compiler can determine the truth value of a logical expression by only evaluating the first Boolean operand. This is known as short-circuited evaluation. Short-circuited evaluation only works with expressions that use ampersand or pipes, so AND or OR. In an expression that uses OR operator, the resulting value will be true as long as one of the operands is a true value. If the first operand of an expression is true, we don't need to see what the value of the other operand is to know that the final value will also be true. For example, we can run the following code without error, despite dividing a number by 0 in the second operand because the first operand had a true value. So if 1 is greater than 0, or 2 divided by 0 is equal to 7, just an print line, no errors here. An expression that uses the AND operator will only result in true if both operands are true. If the first operand in the expression is false, the entire value will be false. Let's write a message inside the reservation constructor that warns against bad input. Our restaurants can't seat parties of more than 8 people. We don't want reservations for 0 or less because that would be silly. Inside reservation, write a conditional that uses OR. So if count is less than 1, or count is greater than 8, logical not. So let's make inform user more informative. If their reservation is not confirmed, they should know. Write an if then else statement and use not is confirmed. If the reservation is not confirmed, write combining conditional operators. We have the ability to expand our Boolean expressions by using multiple conditional operators in a single expression. For example, Boolean foo equals true and not false or not true. How does an expression like this get evaluated by the compiler? The order of evaluation when it comes to conditional operators is as follows. Conditions placed in parentheses, not, and, or. Using this information, let's dissect the expression above. So I get it. Take a look at the 3 expressions in operators.java. Using your understanding of the order of execution, find out whether the value of each expression is true or false. When you're ready, uncomment the print statements to find out if you're right. So parentheses, not. So A is not equal to A, so that's false. B is greater than or equal to A, that's false. So false or false, so that's false. If A is equal to 7, so false. And that's false, but not that. So it's gonna be true. Yeah. Okay, I'm done. Review. Conditional operators work on Boolean values to simplify our code. They're often combined with conditional statements to consolidate the branching logic. Conditional and ampersand evaluates to true if the Booleans on both sides are true. Conditional or pipes evaluates to true if one or both of the Booleans on either side is true. Logical not, exclamation mark, evaluates to the opposite Boolean value to which it is applied. The complete reservation class is in the code editor. Play around inside main and see if you can create instances that will run every possible conditional branch. I'm all set. The following Boolean expression will evaluate to what value. So if not false and 5 greater than 4, so 5 is greater than 4, so true, true, true. If multiple conditional operators are placed in a single expression, which operator gets evaluated first? Expression, the not operator. What will the following code print? Int choice equals 5, switch choice 5, Layla A Lee. What will the following code print if 5 is greater than 6? Else if 6 is less than 5, else gym socks. The OR logical operator is represented in Java by which operator? The pipes. The AND is represented by the ampersands. The break keyword is important in a switch statement, due to which of the following? Without break, Java will continue to check other cases in the switch statement. Cool. No, thank you. Goodness. So the reason I don't do these is because the only reason I'm taking these courses is to complement the Java course I'm taking right now in school. And so I'm really preparing for my final project in that course. And so doing these projects feels like not the best use of my time. I'm really trying to speed run through these courses anyway, just to get that solid foundational, really refreshing the solid foundational memory. Before I get into arrays, I'm gonna get some more coffee. So we have seen how to store single pieces of data in variables. What happens when we need to store a group of data? What if we have a list of students in a classroom? If we were storing 5 lottery ticket numbers, for example, we create a different variable for each value. I get it, arrays, 0 indexed in newsfeed.java. I've created a newsfeed class to keep track of trending articles and their associated views and ratings. We did this using Java arrays, which you'll learn about throughout the lesson. For now, run the code to see some of our methods. So string array, trending articles, int array, views, double array, ratings, so on. Creating an array explicitly. Imagine that we're using a program to keep track of the prices of different clothing items we want to buy. We would want a list of the prices and a list of the items they correspond to. To create an array, we provide a name and declare the type of data it holds. So double array prices. Just like with variables, we can declare and initialize in the same line. This allows us to explicitly initialize the array to contain the data we want to store. Double array prices, 13.15, 15.87, 14.22, 16.66. We can use arrays to hold strings and other objects as well as primitives. So string array, clothing items, tank top, beanie, funny socks, corduroys. We have an empty newsfeed class that does not store anything yet. First, make a method called getTopics. What does it return? Okay. Returns a string array. It's not taking any parameters. Oh, okay, I see. Inside the getTopics method, create a string array called topics. So, and set it equal to an array containing these elements in order. Opinion, tech, science, return topics from the method. Uncomment the lines. Oops, what I do wrong? I see. That's so stupid. Like, why are we signifying arrays in the type declaration with square brackets, and then when we actually define the array, we're using curly braces? Feels silly. Whatever. That's part of why I don't like Java, but it's okay. I'll grow to love it. Uncomment the lines in the main method to see how the get topics method works on a newsfeed instance. So it's returning the memory address. When we printed out the array we created in the last exercise, we saw a memory address that did not help us understand what was contained in the array. If we want to have a more descriptive printout of the array itself, we need a toString method that is provided by the arrays package in Java. So import Java. So we put this at the top of the file before we even define the class. When we import a package in Java, we are making all of the methods of that package available in our code. The arrays package has many useful methods, including arrays.toString. When we pass an array into arrays.toString, we can see the contents of the array printed out. Import java.util arrays, public class lottery, public static void main string args, int lottery, so int array, lottery numbers are those, string, so and so on. This, so string better printout equals arrays.toString lottery numbers, system.out.println better printout. Okay. In order to make our printout of the topics array more helpful, we are going to want to use the toString method from the arrays package. So first import it. Now that you have the arrays package, use its toString method to print out the topics array in the main method. So get element by index. Now that we have an array declared and initialized, we want to be able to get values out of it. We use square brackets to access data at a certain index. So prices square brackets 1 is 15.87. This happens because it's the item at the 1 index of the array. Remember, it's 0 indexed. If we try to access an element outside of its appropriate index range, we'll receive an array index out of bounds exception error. So if we have augmented the newsfeed class to start with the topics array as an instance field, fill in the get top topic method to return the 0th index of the topics array. Get top topic, return topics 0. But wait, we added more to the newsfeed class. Now each instance starts with an array of zeros called views. As an instance field, every time someone views a topic, we want to increment the value of the appropriate field in views. For example, if someone views an opinion piece, we want to increase the value of the 0th index of views from 0 to 1. If they view it again, we want to increase the value to 2. We have written a method signature for view topic, which takes in an int called topic index. Inside the method, set the value of the views array at the index topic index to the current value plus 1. So creating an empty array. We can also create empty arrays and then fill the items one by one. Empty arrays have to be initialized with a fixed size. So string array menu items equals new string 5. Once you declare this size, it cannot be changed. This array will always be of size 5. After declaring and initializing, we can set each index of the array to be a different item. The group of commands has the same effect as assigning the entire array at once. We can also change an item after it has been assigned. Now the array looks like that. When we use new to create an empty array, each element of the array is initialized with a specific value depending on what type the element is. For example, consider the following arrays. Because a string is a reference to an object, my names will contain 5 nulls, my ages will contain 5 zeros to begin with. We now want a newsfeed to be able to keep track of a user's top 10 articles. We've declared a string array called favorite articles, but we haven't initialized it yet. In the constructor for newsfeed, set favorite articles to be a new empty string array of size 10. Inside the method set favorite article, set the value of the favorite articles array at index favorite index. To be the value of new article. For example, if I called set favorite article 2, celebrity hands throughout the decades, the value of favorite articles at index 2, we set to, okay, gotcha. It's a stupid article, by the way. Length, what if we have an array storing all the usernames for our program and we want to quickly see how many users we have? To get the length of an array, we can access the length field of the array object. So menu items.length, this command would print 5 since the menu items array has 5 slots, even though they are all empty. If we print out the length of the prices array, prices length, we would see 4 since there are 4 items in the prices array. In the method getNumTopics, return the length of the topics array. String args. When we write main methods for our programs, we use the parameter string array args. Now that we know about array syntax, we can start to parse what this means. A string array is an array made up of strings. Examples of string arrays, so string array humans, string array robots. The args parameter is another example of a string array. In this case, the array args contains the arguments that we pass in from the terminal when we run the class file. So far, args has been empty. So how can you pass arguments to main? Let's say we have this class hello_u, public class hello_u, public static void main string array args, system.out.println hello plus arg0. When we run the file hello_u in the terminal with an argument of Laura, Java hello_u Laura, we get the output hello Laura. The string array args would be interpreted as an array with one element Laura. When we use arg0 in the main method, we can access that element like we did in hello_u. We want to give the user an option to make a newsfeed object for robots or for humans. We will take either robot or human as an argument to the main method when the newsfeed.java file is run. If the args array holds human, we will initialize the feed with human topics. If the args array holds robot, we will initialize the feed with robot topics. Replace the blank in the conditional statement to reflect this expected control flow. So if arg0 dot equals human, else if args0 equals robot. In the terminal, run the newsfeed.java file with the argument robot. Now run the newsfeed.java file with argument human. Can I assume that it's compiled? I guess I will. We've now seen how to store a list of values in arrays. We can use this knowledge to make organized programs with more complex variables. Throughout the lesson, we've learned about creating arrays explicitly using curly braces, accessing an index of an array using square brackets, creating empty arrays of a certain size and filling the indices one by one, getting the length of an array using length, using the argument array args that is passed into the main method of a class. In order to practice the skills you've learned throughout the lesson, we're going to make and use some arrays in the main method of a new classroom class. First, inside main, make a string array called students. Now we're going to store the averages. What did I do wrong? Oh yeah. Now we're going to store the averages on the most recent math test. Create an array called math scores. Set equal to an empty array of size 4, it should hold doubles. Sadie got a 94.5 on the test. Store this value in the 0th index of the math scores array. Sam got a 76. Store this value in the appropriate spot in the math scores array. Write a print statement to say the number of students in the class is num students. I'm trying to remember how to I'm getting my Swift and Java mixed up right now. I think it's, how do you do this in Java? The number of students in the class is, I think it just does it automatically actually. Students.length. Cool. Fill in the code to print the array so that its actual values display instead of the memory address. So we have specials system.println arrays to string specials. Fill in the code to set tax rates to be an empty array of size 10 holding doubles. So double tax rates equals new double 10. What type is the following object? Say int array. How would you access the element gorgeous? So the following array, 0, 1. What property holds the number of elements in an array? What would be printed out by the following code if a user ran the command Java restaurant 6 vegetarians, string args, system.out.println table for a party of 6 if argument 1 is equal to vegetarians, do something. Table for a party of 6. Cool. When we work with arrays in Java, we've been limited by the fact that once an array is created, it has a fixed size. We can't add or remove elements. But what if we needed to add to the book lists, news feeds, and other structures we were using arrays to represent to create mutable and dynamic lists? We can use Java's ArrayList class. ArrayList allows us to store object references as elements, store elements of the same type, just like arrays, access elements by index, just like arrays, add elements, remove elements. Remember how we had to import java.util.arrays in order to use additional array methods? To use an array list at all, we need to import them from Java's util package as well. In shopping.java, we've defined 2 arrays, grocery items, a string array, price is a double array. We've tried to add a new item to the end of each. Run the code, does it work? Exception in thread main, array index out of bounds exception. Creating array list. To create an array list, we need to declare the type of objects we'll hold, just as we do with arrays. So array list, string, baby names. We use angle brackets to declare the type of the array list. These symbols are used for generics. Generics are a Java construct that allows us to define classes and objects as parameters of an array list. For this reason, we can't use primitive types in an array list. This code won't compile. Array list int ages. This code will compile. Array list integer. integer generic has to be used in an array list instead. You can also use double and character for types you would normally declare as doubles or chars. We can initialize to an empty array list using the new keyword. So we're declaring this array list of integers, ages, and initializing ages equals new array list integer, declaring and initializing one line array list string baby names equals new array list string. Import the array list package from java.util. So create a new array list that will contain string elements and call it to-do list. So what am I doing wrong? Adding an item. Now we have an empty array list, but how do we get it to store values? Array list comes with an add method, which inserts an element into the structure. There are two ways we can use add. If we want to add an element to the end of the array list, we'll call add using only one argument that represents the value we are inserting. In this example, we'll add objects from the car class to an array list called carshow. Array list car, carshow equals new array list car. Carshow.add Ferrari. Carshow now holds Ferrari. Carshow.add Thunderbird. Carshow now holds Ferrari Thunderbird, and so on. If we want to add an element at a specific index of our array list, we'll need two arguments in our method call. The first argument will define the index of the new element, while the second argument defines the value of the new element. By inserting a value at a specified index, any elements that appear after this new element will have their index value shifted over by 1. Also note that an error will occur if you try to insert a value at an index that does not exist. When using array list methods like add, the reference parameters and return type of a method must match the declared element type of the array list. For example, we cannot add an integer type value to an array list of string elements. We've discussed how to specify the element type of an array list. However, it is possible to create an array list that holds values of different types. In the following snippet, assortment is an array list that can store different values because we do not specify its type during initialization. In this case, the items stored in this array list will be considered objects. As a result, they won't have access to some of their methods without doing some fancy casting. Although this type of array list is allowed, using an array list that specifies its type is preferred. We've created an empty array list called to-do list. Time to add some to-dos. Below where we've initialized to do 1, initialize two new string variables, to do 2 and to do 3. So to do 2, to do 3. Read books. Set their values to any task you like. Done. Use .add to add to do 1, to do 2, and 3 to to-do list. So so array list size, gotcha. So it's dot size. Detectives do a lot to solve a case, but who has more to do? Print out the size of each detective's to-do list array. Sherlock to-dos, so print the size of each array below. So, uh, so who has more to do? Print the name of the detective whose to-do list is longer. So um, accessing an index. With arrays, we can use bracket notation to access a value at a particular index. Double array ratings equals those. System.out.println ratings 1. This code prints 2.5, the value at index 1 of the array. For array lists, bracket notation won't work. Instead, we use the method get to access an index. So shopping cart.get2. This code prints magnifying glass, which is the value at the index 2. Use get to access the third to-do element of Sherlock's to-dos. Sherlock's to-dos by get. Use get to access the second to-do element of Poirot's. Changing a value. When we were using arrays, we could rewrite entries by using bracket notation to reassign values. So string array shopping cart equals trench coat tweed houndstooth hat magnifying glass. Shopping cart 0 equals tweed cape. Now holds tweed cape, tweed houndstooth hat, and magnifying glass. Array list has a slightly different way of doing this, using the set method. Modify Sherlock's to-dos so that the value at play violin becomes listen to Dr. Watson for amusement. Modify Poirot's to-dos so that the value at trim mustache becomes listen to Captain Hastings for amusement. Removing an item. What if we wanted to get rid of an entry altogether? For arrays, we would have to make a completely new array without the value. Luckily, array lists allow us to remove an item by specifying the index to remove. So array list string shopping cart equals new array list string. And we can add them and then do shopping cart dot remove one. We can also remove an item by specifying the value to remove. Similarly, this command removes the first instance of the value trench coat. Sherlock Holmes and Hercule Poirot have each already visited their respective crime scenes. Remove visit the crime scene from Sherlock's to-dos and Poirot's to-dos using remove. So oh, getting an item's index. What if we had a really large list and wanted to know the position of a certain element in it? For instance, what if we had an array list detectives with the names of fictional detectives in chronological order, and we wanted to know what position Fletcher was? So system.out.println detectives.index of Fletcher. This code would print 4, since Fletcher is at index 4 of the detectives array list. After visiting the crime scene, the ever-impatient Dr. Watson wants to know how many to-dos are left until Sherlock solves the case. To help Dr. Watson figure this out, use index of to determine where in the to-do list solve the case is. Print this information out. That's the number of to-dos remaining before Sherlock reaches solve the case. Nice work. You now know the basics of array lists, including creating an array list, adding a new array list item using add, accessing the size of an array list using size, finding an item by index using get, changing the value of an array list item using set, removing an item with a specific value using remove, retrieving the index of an item with a specific value using index of. Now, if only there was some way to move through an array or array list item by item, we've included a workspace for you to test out your newfound knowledge of arrays and array lists. Remember to run your code and the following commands in the terminal. Blah, blah, blah. Fill in the blank to declare the array list. To hold the correct type, import java.util.arraylist, public class gradebook, public static void main string list args or string array args, array list. So we need to declare the array list to hold the correct type. So array list integer. What does the following code print? Import java.util.arraylist, public class rating machine, public static void main string array args, array list double ratings equals new array list double. So we're adding 1.7, 2.5, 3.1, and then we're removing 1. It's going to get an error. Oh, no. Remove 2.5. So then we get 3.5. Fill in the code to print out how many elements are stored in the grades array list. Import java.util.arraylist. So it's going to be grades.size. What will the following code print? So temperatures, array list of integers, temperatures at 78, 67, 89, 94. We're getting 2, so it's going to get 89. What will the array list kids movies hold after the code is run? So kids movies, Moana, Up, Wally, and then we're going to set 0 to Babe, so it's going to be Babe, Moana, Up, Wally. It's okay. What will the array list usernames hold after this code runs? Usernames, it was New ArrayList. Usernames, Terracoder, Java Knight. Am I paying attention this time? I think it'll be Terracoder, Java Knight. Cool. What method can you use to find the position of a specific element in an array list? Index of. Cool. Spare me, you know? Loops. It's a cool looking animation. I'm gonna give it a second, so I'll be right back. You know, I'm a little bored. That's okay. It's okay to be bored. So much of life is just about building up endurance to doing things that might feel boring. But the feeling will pass, and it's good. You know, I want to get these fundamentals as solidly grounded. There's, probably going to be many times in my life where I have to come and revisit the fundamentals of coding. Right now, I'm sort of going broad before I go deep, meaning I'm learning several different languages at once. And I think as I get more into a career, as I get more into specific project work, it'll be more sensible at that point. It's throwing me off how much bigger this car is than these cars, but whatever. It'll be more sensible to go deep. But for right now, going broad makes sense to me. I also don't really have much of an option. I mean, I'm taking 2 different courses, so unless I were only focusing all my attention on C++ and Java, which I don't really want to do because, I want to work with AI, so Python is relevant, and I want to build an app right now for my phone, so Swift is relevant. And then I also want to learn like AWS, and I guess that covers really the main things I want to learn right now. Oh, and also math, like statistics, discrete math. There's a lot to learn. And the more I learn coding, sort of the more I get this desire to learn math, because it's like it's similar to how I've talked in the past about how being a master of C or C++ feels a little sexier than being a master of Python, just because it's a lower level language and it's more complex. In a similar way, being a master of statistics and mathematics seems like it has a little bit of an attractive veneer, which is what I mean when I'm saying sexy. But there's a veneer to it that's like, all right, he understands it from the ground level. He understands the secrets of the universe, in the most abstract way. Like, and I want to understand all of this stuff. There's so much to learn in so little time, but yeah, I mean, I definitely got to take a statistics course on here after I guess after my school semester probably, or at least after my final projects are done. So I have like a month until then. And then I'm gonna bang out a statistics course in like probably less than a week. I want to get a solid understanding of it, but on here it's cool. You can kind of just get like an introduction to things, a basic understanding, a good enough understanding, I'll say, and then you can kind of pursue your interest more deeply after this. Like for example, I'm taking a Swift course on here, and really I just want to get a solid enough understanding of using Swift and Xcode, and then I'm probably gonna go to like GitHub and look for some repositories people have made of specific projects that are more in line with what I want to build. But you can't just really jump in. I mean, you could, but I found that it's really useful to get like a fundamental understanding of something before you just jump into working from a repo and trying to like go to Google and ChatGPT and stuff, asking like, what does this statement mean? If you had a fundamental understanding, you would know, and it just would feel, even if it might take a week or 2 weeks to build something with getting that fundamental understanding first, whereas it might only take you like half the time or 3/4 of the time. The stress, I'm saying, if you just jumped in directly without taking a course, the stress levels will be lower if you understand basically how to read something. So that's why, even though I'm feeling bored right now, I understand this is going to contribute to having lower stress levels later. And that's what it's about. I'd rather be bored right now and secure later than stressed right now and stressed later. If that makes sense. All right. So, introduction to loops. I get it. I don't got to read that. So, while we're here, a while loop looks a bit like an if statement. While silliness is greater than 10, code to run. Like an if statement, the code inside a while loop will only run if the condition is true. However, a while loop will continue running the code over and over until the condition evaluates to false. So the code block will repeat until silliness is less than or equal to 10. So set attempts to 0, int attempts equals 0, enter loop if condition is true, while passcode is not equal to 0524 and attempts is less than 4. System.out.println, try again, passcode equals get new passcode, attempts plus equals 1. While loops are extremely useful when you want to run some code until a specific change happens. However, if you aren't certain that change will occur, beware the infinite loop. Got you. So take a look at luckyfile.java. We've set up a random number generator that allows you to simulate the roll of a die. Create a while loop that will continue to loop while die roll is not 5. Do not run your code yet. You will get an infinite loop here because the value of die roll is never changed. Inside the loop, reset die roll with a new random value between 1 and 6. Inside the while loop, above the line where you reset die roll, print out die roll. Incrementing while loops. When looping through code, it's common to use a counter variable. A counter, also known as an iterator, is a variable used in the conditional logic of the loop and usually incremented in value during each iteration through the code. For example, counter is initialized, int wishes equals 0. Conditional logic uses counter while wishes is less than 3. System.out.println wish granted. Counter is incremented wishes plus plus. In the above example, the counter wishes gets initialized before the loop with a value of 0. Then the program will keep printing wish granted and adding 1 to wishes as long as wishes has a value of less than 3. I get it. Got you. Sorry, I'm just... Okay. In coffee.java, initialize an int variable called cups of coffee with a value of 1. create a while loop that runs as long as cups of coffee is less than or equal to 100. Inside the while loop, above where you incremented cups of coffee, print the following. For loops. Incrementing with loops is actually so common in programming that Java, like many other programming languages, uses syntax specifically to address this pattern: for loops. A for loop header is made up of the following three parts, each separated by a semicolon: the initialization of the loop control variable, a Boolean expression, an increment or decrement statement. The opening line might look like this: for int I equals 0, I less than 5, I plus plus, code that will run. In a for loop, an initialization statement is run once in order to initialize the loop control variable. This variable is modified in every iteration, can be referenced in the loop body, and used to test the Boolean condition. In the example above, I is the loop control variable. Let's break down the above example. I equals 0, I is initialized to 0, I less than 5. The loop is given a Boolean condition that relies on the value of I. The loop will continue to execute until I less than 5 is false. I plus plus I will increment at the end of each loop and before the condition is reevaluated. So the code will run through the loop a total of 5 times. We'll also hear the term iteration. Gotcha. Using for loops. So even though we can write while loops that accomplish the same tasks, got you. Fortunately, it's important to be aware if we don't create the correct for loop header, we can use the iteration loop one too many. So for example, imagine we wanted to find the sum of the first 10 numbers and wrote the following: int I equals 0, I less than 10, I plus plus, sum plus equals I. Gotcha. We've provided a while loop that loops from 1 to 100, outputting a string on each iteration. Rewrite this code as a for loop. Remember the syntax. So for for int cups of coffee equals 1, cups of coffee less than or equal to 100, cups of coffee plus plus. Wow. Iterating over arrays and array lists. One common pattern we'll encounter as a programmer is traversing or looping through a list of data and doing something with each item. In Java, that list would be an array or array list, and the loop could be a for loop. But wait, how does this work? In order to traverse an array or array list using a loop, we must find a way to access each element via its index. We may recall that for loops are created with a counter variable. We can use that counter to track the index of the current element as we iterate over the list of data. Because the first index in an array or array list is 0, the counter would begin with a value of 0 and increment until the end of the list. So we can increment through the array or array list using its indices. For example, if we wanted to add 1 to every int item in an array secret code, we could do this. For int I equals 0, I less than secret code dot length, I plus plus, increase value of element value by 1. Secret code I plus equals 1. Because that, notice that our condition in this example is 1 less than secret code dot length. Sorry, I less than secret code dot length, because array indices start at 0. The length of secret code is 1 larger than its final index. A loop should stop its traversal before its counter variable is equal to the length of the list. To give a concrete example, if the length of an array is 5, the last index we want to access is 4. If we were to try to access index 5, we would get an array index out of bounds exception error. This is a very common mistake when first starting to traverse arrays. Traversing an array list looks very similar for int I equals 0, I less than secret code dot size, I plus plus, increase value of element value by 1, int num equals secret code dot get I, secret code dot set I, num plus 1. We can also use while loops to traverse through arrays and array lists. If we use a while loop, we need to create our own counter variable to access individual elements. We'll also set our condition to continue looping until our counter variable equals the list length. For example, let's use a while loop to traverse through an array list. Int I equals 0, initialize the counter, while I is less than secret code dot length, secret code I plus equals 1, I plus plus, increment the while loop. Traversing through an array list with a while loop would look like this. Int I equals 0, initialize counter, while I is less than secret code dot size, int num equals secret code dot get I, secret code dot set I, num plus 1, I plus plus, increment the while loop. Let's use a for loop to iterate over expenses and sum up the total of all items. Start with the skeleton of a for loop, initialize a counter I with a value of 0. The loop should run while I is less than the size of expenses. Increment I. Inside the for loop, add the item's value to total. Break and continue. If we ever want to exit a loop before it finishes all its iterations or want to skip one of the iterations, we can use the break and continue keywords. The break keyword is used to exit or break a loop. Once break is executed, the loop will stop iterating. For example, for int I equals 0, I less than 10, I plus plus, system.out.println I. If I is equal to 4, break. Even though the loop was set to iterate until the condition I less than 10 is false, the above code will output the following because we used break. The continue keyword can be placed inside of a loop if we want to skip an iteration. If continue is executed, the current loop iteration will immediately end and the next iteration will begin. We can use the continue keyword to skip any even valued iteration. This program would output the following. In this case, if a number is even, we hit a continue statement, which skips the rest of that iteration, so the print statement is skipped. As a result, we only see odd numbers print. Loops can exist all throughout our code, including inside a method. If the return keyword was executed inside a loop contained in a method, then the loop iteration would be stopped and the method/constructor would be exited. For example, we have a method called check4jacket that takes in an array of strings. If any of the elements are equivalent to the string value jacket, the method will return true. So public static boolean check4jacket string list args. For int I equals 0, I less than list.length. So I said string list args, I meant string array list. So list.length, I plus plus, system.out.println, list I. If list I is equal to jacket, return true, return false. So, you get it. As soon as an element equals jacket, return true is executed. This causes the loop to stop and the compiler to exit check4jacket. Running the code would output the following: shirt jacket true. Take a look at the for loop in the code editor. It starts its iteration at 0 and continues to iterate until I is less than 100 is false. Inside the loop, create a condition that checks if I is not divisible by 5. So finds I modulo 5, checks if it's equal to 0. And if this is not the case, so if it's not true, Outside the condition statement, print I. I did it. I just didn't do the way you want me to do it. So show me how you want me to do it. Whatever. For each loops, sometimes we need access to the element's indices, or we only want to iterate through a portion of a list. If that's the case, a regular for loop or while loop is a great choice. For example, we can use a for loop to print out each element in an array called inventory items. For int inventory item equals 0, inventory item less than inventory items dot length, inventory item plus plus, print element at current index, system.out.println, inventory items, inventory item. But sometimes we couldn't care less about the indices, we only care about the element itself. Times like this, for each loops come in handy. For each loops, which are also referred to as enhanced loops, allow us to directly loop through each item in a list of items, like an array or array list, and perform some action with each item. If we want to use a for each loop to rewrite our program above, the syntax looks like this: for string inventory item in inventory items, print element value, system.out.println, inventory item. Our enhanced loop contains two items, an enhanced for loop variable, inventory item, and a list to traverse through inventory items. We can read the colon as in, like this. For each inventory item, which should be a string, in inventory items, print inventory item. If we try to assign a new value to the enhanced for loop variable, the value stored in the array or array list will not change. This is because for every iteration in the enhanced loop, the loop variable is assigned a copy of the list element. We can name the enhanced for loop variable whatever we want. Using the singular of a plural is just a convention. We may also encounter conventions like string word in sentence. Let's use a for each loop to find the priciest item in expenses. So for double iterates through each expense and expenses. Inside the for each loop, check if expense is greater than most expensive. If it is, set most expensive equal to expense. Removing elements during traversal. If we want to remove elements from an array list while traversing through one, we can easily run into an error if we aren't careful. When an element is removed from an array list, all the items that appear after the removed element will have their index value shift by -1. It's like all elements shifted to the left. We'll have to be very careful with how we use our counter variable to avoid skipping elements. Removing an element while using while. When using a while loop and removing elements from an array list, we should not increment the while loop's counter whenever we remove an element. We don't need to increase the counter because all of the other elements have now shifted to the left. For example, if we removed the element at index 3, then the element that was at index 4 will be moved to index 3. If we increase our counter to 4, we'll skip that element. Take a look at this block of code that will remove all odd numbers from an array list. Think about what the value of I is when we're increasing the value of I, and when I is less than list.size becomes false. Int I equals 0, while I is less than list.size. If value is odd, remove value. If list.getI modulo 2 is not equal to 0, list.remove I. Else, if value is even, increment counter I plus plus. removing an element using for. We can use a similar strategy when removing elements using a for loop. When using a while loop, we decided to not increase our loop control variable whenever we removed an element. This ensured that we would not skip an element when all of the other elements shifted to the left. When using a for loop, we unfortunately must increase our loop control variable. The loop control variable will always change when we reach the end of the loop, and it will usually change by 1 because we often use something like I++. Since we can't avoid increasing our loop control variable, we can take matters into our own hands and decrease the loop control variable whenever we remove an item. For example, for int I equals 0, I less than list.size, I++. If list.getI is equal to value to remove value from array list, list.remove list.getI, decrease loop control variable by 1, I minus minus. Now, whenever we remove an item, we'll decrease I by 1. Then, when we reach the end of the loop, I will increase by 1. It will be like I never changed. Avoid manipulating the size of an array list when using an enhanced for loop. Actions like adding or removing elements from an array list when using a for each loop can cause concurrent modification exception error. Take a look at the code placed in the main method of the lunch class. So we have an array list string, lunch container, new array list string, lunch container. We're adding a bunch of things to the lunch container. Lunch container equals remove ants, lunch container. So we put some ants in there, some outprint lunch container. Inside the method remove ants, use a for loop or a while loop to iterate. So for item in lunchbox, if string cannot find symbol. So for string item in lunchbox, if item is equal to ant, lunch, yeah, that's the whole point, right? I know. So, okay, that's what they told me. So string, so okay, for int I equals 0, I less than lunchbox size, I++, if lunchbox I is equal to ant lunchbox.remove I and I minus minus, right? Oh boy, I'm messing this up, huh? All right, let's think about it, right? Let's actually try. Let's try. So, iterate through the lunchbox array list. So, so we'll do a for loop because I like them. So for int I equals 0, I less than array list dot size I plus plus, and we'll check if item is a int. So if array list dot get the item at I is equal to int, delete it, or else I remove it. Array list dot remove I, and then we need to good then. So then, so 0, 1, 2, 3, 4. So this pass, so pass 1. And then I is 1. Remove it. Now I is 2, but it goes just to sandwich. So we need to do I minus minus. Oh, I see. Okay, now I understand. Lunchbox. Missing return statement. Nice. All right, that got serious at the end there. I like that. Nice work. Let's iterate over what we've just learned about loops. While loops, these are useful to repeat a code block an unknown number of times until some condition is met. For example, int wishes equals 0 while wishes is less than 3. Wishes plus plus. For loops, these are ideal for when you are incrementing or decrementing with a counter variable. For example, for int I equals 0, I less than 5, I plus plus. For each loops, these make it simple to do something with each item in a list. For example, for string inventory item in inventory items. Feel free to play around with loops, arrays, and array lists in the code editor. I think I'll pass on that. Let's take the quiz. When would it be helpful to use a for loop instead of a for each loop when iterating over an array list of items? When each item in the array list has a different value, when you're worried about causing an infinite loop, when you aren't starting from the beginning of the array list, when you don't know how long the array list will be. See, I want to say when you're worried about causing an infinite loop, but I also feel like when you aren't starting from the beginning of the array list, it would make more sense to do a for loop than a for each loop. Complete the for loop so that it won't cause an infinite loop. So for int I equals 0, I less than 5, I plus plus. Rebuild the while loop as a for loop. So while I is greater than 0, system.out.println, I plus bottles of soda on the wall, I minus minus. For int for int j equal 99, j greater than 0, j minus minus. 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 J greater than 0, j minus Complete the for each loop for string llama in llamas. How many times will hello IT have you tried turning it off and on again? Be printed to the console. Int I equals 1 while I is less than 100. System out dot print line hello IT. If you try turning it off and on again, I plus plus. So I starts at 1 while it's less than 100. So if you started at 0, it print once. So I'm pretty sure 100 times. Baby bad. So stupid. Alright, how can you modify this code so that it won't cause an infinite while loop? Int I equals 7 while I is greater than 0. System out dot print line I. So while I is greater than 0, you need an I minus minus inside the while loop. Okay, it's fine. Not mad or anything, it's fine. Objective fizz buzz. Classic. As the inventor of this challenge, Imran Gori states, after a fair bit of trial and error, I've come to discover that people who struggle to code don't just struggle on big problems or even smallish problems, i.e. writing implementation of a linked list. They struggle with tiny problems. So set out to develop questions that can identify this kind of developer and came up with a class of questions I call fizz buzz questions, named after a game children often play or are made to play in schools in the UK. I'm glad I read that because I just wondered what fizz buzz even means. So now I know it's a UK game. Prime directive. Primed for more. String methods. Well, fortunately, I have other stuff I have to get done. So that's it for now. Where are we at in the syllabus? String methods, access, encapsulation, and static methods, inheritance, polymorphism, debugging, two-dimensional arrays. All right, so fun stuff.